Good afternoon, everyone. And today, Denise and Tom will talk about the quotient rule and the trig derivatives. And this is the quotient rule. The quotient rule, when two differentiable functions are divided, the resulting function is also differentiable. Let f and g be differentiable functions, then fx equals f over g is also differentiable. The derivative of f of x over g of x is equal to gx times f prime of x minus fx times g prime of x over gx squared. And square, we cannot forget about it. And the derivative is that low d high minus high d low over the square of what's below. The saying reads to help us remember the derivative equation. And this is a very good sentence for us to think about the function. First, let us see the examples about the derivative. The first derivative we need to find is about y equals 5x minus 2 over x squared plus 1. And the first step, we need to apply these numbers into the formula in the last page. And the y prime equals the x squared plus 1. This is about the gx, and 5 is the f prime of x, which is the derivative of 5x, and we need to minus 5x minus 2. This is the 5x, and 2x is the derivative of the x squared plus 1, and we need to apply the x squared plus 1 square. And next step, we only need to simplify it. It's like this. And the final step, we also need to simplify the last step, and we get our final answer is about negative 5x squared plus 4x plus 5 over x squared plus 1 squared. And we need to see the next example. And the first step, we also need to apply to the function. X plus 5 is a g of gx, and 1 over x squared is equals to f prime of x. It is a derivative of fx, and we need to minus 3 minus 1 over x. This is also the fx, and 1 is the g prime of x. We need to use the power of the x plus 5 squared. The next step is also about the simplify. The final answer is about 5 over x squared plus 2 over x plus 3 over x plus 5 squared. This is the final answer. Let us see the next example. It is fx equals tangent x. The first step, we need to apply the derivative. The cosine x times cosine x minus sine x times negative sine x over cosine square x. The next step is about the simplify. We like the cosine square x plus sine square x over cosine square x. The last step is about the combine. It's over 1 over cosine square x equals secant square x. In this page, we need to know some trigonometric function review. These are the functions which we can apply to our daily formulas. The 1 over sine x equals secant cosecant x. The 1 over cosine x equals secant x. 1 over tangent x equals cotangent x. Cotangent x equals cosine x over sine x equals to cosecant x over secant x. Also, the most essential thing is about the sine square x plus cosine square x equals 1. These are also some the formulas about the derivatives of trigonometric functions. we have learned these functions before, but we also need to remember about it. The derivative of sine x is equals to cosine x. The derivative of cosine x equals negative sine x. The derivative of tangent x equals secant square x. The derivative of cosecant x equals negative cosecant x times cotangent x. The derivative of secant x equals to secant x times tangent x. The derivative of cotangent x equals to negative cosecant square x. These are also some examples about the topics we need to practice. The first is about the y equals 2x minus tangent x. Here we also need to apply to two steps. That is the derivative of 2x and the derivative of tangent x. And here this is not x, this is 2, and the final answer is about 2 minus secant square x, and we know the tangent x derivative is about the secant square x. The next step we need to apply to the formula that g of x times f prime of x minus f of x times g prime of x over g of x squared. Here, the secant x we need to apply to that formula, and the process is about the secant x times cosecant x times dx minus 1 minus cosecant x times secant x times tangent x over secant square x. The last step is about the simplify, and this is the final answer. The next example is about y equals sine x times tangent x, and in this example we can apply to the function that f prime of x times g of x minus g prime of x times f of x. And here we apply to that formula, and we can get our final answer. And in the next topic, Tom will explain about the homework.
So the first question is x over x squared plus 1. And this question is, so first we need to write f derivative x equal to, look, the x squared plus 1 is moved in front, so it's x squared plus 1 times 1 minus x times 2x and over x squared plus 1 square. So the next step is simplify it. So it become x squared plus 1 minus 2x squared over x squared plus 1 square. So this is our final answer. So in next question, it's hx equal to x square 1 over 2 over x cube plus 1. So the first step is x cube plus 1 times 1 over 2x times negative 1 over 2 minus x times x 1 over 2 square times 3x square and over the x cube at 1 square. So in the next step, the hx equal to 1 over 2 times x 5 over 2 plus 1 over 2 times x negative 1 over 2 and minus 3x 5 over 2 over the 3 cube plus 1 square, and simplify it. It's become our final answer. So in the next question, g of x equal to x squared times cosine x, sin x over x squared. So we will change it into like x squared times cosine x minus sin x times 2x over x squared squared. So it's become x squared times cosine x minus 2x times sin x and over x fourth square. So in question 40, fx equal to x plus 1 times cosine x. So in this question we should separate the equation and it's become 2x plus 1 times negative sin x plus cosine x times 1. So there is the derivative of cosine and there is derivative of x. So x become 1 and cosine x become derivative cosine x equal to negative sin x. So in the next step is just to simplify it. So it becomes to negative x sin x minus sin x plus cosine x. So in the next question, it's just to derivative it. So you can see here, negative x equal to derivative negative x equal to negative 1 and derivative tangent x equal to secant square x. This is basically separates each by each to derivative. So in the next step, y equal to x plus cotangent x. So in this step is similar to last step, so it's just separate x and cotangent x and then derivative each by each. So in the next question is g of t equal to t to the power 1 over 4 plus 6 cosecant x. So it becomes 1 over 4 times t to the power 1 times 1 over 4 minus 6 secant t and cotangent t, which is similar to last two questions, just derivative step by step. And this is our final answer. Just to simplify it. Okay, in this question, hx equal to x to the power negative 1 minus 12 times secant x. So we need a derivative it each by each. So x to the power negative 1 becomes negative x to the power negative 2 and minus 12 secant x times tangent x. So the derivative of 12 secant x equal to 12 secant x times tangent x, and then simplify it, it becomes our final answer. In the next question, it's fx equal to x over x plus 4. This time we need to use the same method as we talked about that quotient rule. So it's d over dx times fx over gx equal to gx times f derivative x minus fx times g derivative x over g times x squared. So in this question, x plus 4 is gx and x is fx. So with derivative x first become 1 and then we will derivative g of x, which is x plus 4, so it's become x, and we have gx squared, so it's x plus 4 squared. So next is simplify it. Then we will get 4 over x plus 4 squared. And then we replace x by -5. So it becomes 4 over -5 plus 1 squared. And it's finally equal to 4. So it's y minus 5 equal to 4 times x plus 5. So in the next question, it's also the quotient rule we need to apply. So the f derivative x equal to, look, this one is g of x and this is fx. So g of x, fx. So we need derivative fx first. So it's become 2x. And here we derivative gx. So it becomes 1. So and there is g of x squared. So become negative x minus 1 squared. And then we need to simplify it. So it becomes x squared minus 2x over x minus 1 squared. So it's finally become x squared minus 2x equal to 0. And further develop it becomes x times x minus 2 equal to 0. And it becomes x equal to 0 and x equal to 2. And this is our seat. 0, x is 0 and y is 0 and x is 2, y is 4. And in the next question, 81, we have fx and gx. This is basically our rule. So we will derivative fx first minus fx times g derivative of x and over gx squared. So in next question, so we replace 4 in here and it becomes 3 times -1 minus 7 times 0. It's and over 3 to the power 2. So it becomes to -1 over 3. And this is 82. It becomes 4 times 2 minus 4 times -1, and it finally becomes 3 over 4. And this is 86. P to the derivative t equal to 500 times 2000 t over 50 plus t squared. So we also use the quotient rule that this is f of g and this is f of x. This is g of x and this is f of x. And so we derivative it and become and there add square on it, so it's finally become 23,000 over 729, and it's finally become 31.55. And the last question, that's fx equal to x over x minus 1 and f derivative x equal to x minus 1 times 1 minus x times 1, and it becomes x minus 1 squared. So we need to further simplify it, and it's finally become 2x minus 2 over x to the power 4 equal to 2 over x plus x minus 1 to the power 3. And the next question, fx equal to secant x. F derivative x equal to secant x times tangent x, which is the formula that we talked before. It's named trigonometry function review. So it's and we derivative it again. So it becomes secant x times secant x square times x plus tangent x times secant x times tangent x. And we further simplify it. It becomes secant to the power 3 times x plus secant x times tangent square x. This is our final answer. And in the next question, f to the x equal to 2gx plus hx. So we need to separate each of the term and to derivative each by each. So it becomes 2 times negative 2 times g of x and h derivative x. So it becomes f derivative 2 equal to 2 times negative 2 plus 4, and then simplify it equal to f derivative 2 equal to 0. F to the derivative x equal to negative hx. So next is f derivative 2 equal to negative h derivative 2. So it will finally become f derivative 2 equal to negative 4. And in the next question, fx equal to gx over hx. So in this question, we should use the quotients rule. That's g of x is fx and h of x is gx. So it's we need a derivative gx first minus we need to derivative fx first and have a gx squared. So it's when we simplify it and plus 2 replace x by 2, so it's become negative 1 times negative 2 minus 3 times 4 over negative 1 squared. So it's finally become negative 10. And in this question, fx equal to gx times hx. So f derivative x equal to gx times h derivative x plus hx times g derivative x. So it becomes, and we need to further derivative it. So we need to replace 2 on it. So it becomes 3 times 4 plus negative 1 times negative 2. So it finally becomes f derivative 2 equal to 14. And this is the graph we need to draw. So just use your calculator. So thanks for your listening.